Hello everyone, I'm Santosh and I welcome you to my channel Learning Bits. So in this video, we are going to discuss how we are going to implement a Bresenham's line drawing algorithm. So usually if we talk about OpenGL program and if I want to draw a line, I can use GL vertex 2 times and GL begin and GL end enclosed within, and I can just give 2 points to draw a line. It will make my job. If I use GL lines primitive or GL line loop primitive, this is going to do my job. But now when I want to draw a line behind the scene, how the OpenGL program is going to draw a line without using primitive, and the way it's going to use the Bresenham's line drawing algorithm, that is what you're going to see in this program. Exactly how we are going to draw the line by just using GL points. I'm not going to use any line primitive, just use GL points, hence I'm going to draw a line, because we are aware a straight line which contains n number of lines or n number of points between the two endpoints. If I take any line with 2 endpoints, in between there will be n number of points. That is where it is going to form a line for us. The same thing we are going to implement right now using Bresenham's line drawing algorithm. How exactly we are going to find these intermediate points to draw in the entire line. Fine. And now when I'm doing this and I'm drawing a line, so we'll make sure the algorithm is going to work for all the types of slopes. Fine. I'll just tell you what types of slopes are available and how we're going to work upon this. But my main concentration will be on how to implement a Bresenham's line drawing algorithm. Fine. So just look at this. So when I'm going to draw a line, so if I call this as x1, x2, and if this is x2 and y2, now if you just observe, when I'm drawing a line, it is not just a single set of pixels. So sometimes it's going to be a staircase. In a one single line I should be able to choose 2 pixels, or in one single line I should be able to choose only 1 pixel or more than 2 pixels, depending upon what type of slope I'm going to give. So that is what exactly we are going to use the Bresenham's line drawing algorithm. So now just observe here. So whenever we're going to have the first point of the line x1 y1 and the second point of the line, the end point x2 y2. Now I've got 2 pixels. Now these are the 2 pixels for sure, which I'm going to activate with the color of the line what I want. But now in between this, what are all the pixels I'm going to use? That is for every x value. Now if I say this is x, I'm going to have x plus 1, x plus 2, x plus 3, x plus 4. When I reach x plus 4, that is where I'm going to reach x2. So from x1 to x2, for every value of x, I need to find what is the y value is going to be. Either I need to choose this pixel or I need to choose this pixel. Any one value of the y I need to choose whenever I'm going to increment the value of y until I'm going to reach x2. Hence this is, we are going to have x as the increment axis and y is going to be the computing axis, where for every increment of x by 1, I need to find what is the value of y is going to be. That is what the Bresenham's basic idea is going to be all about. That is what, for every value of x from x0, the first point x value until the x end, that is the second endpoint x value. For all these x values I need to find the intersecting y value. Hence x is going to be the constant increment, y is going to be the increment with respect to the slope what I'm going to have. So now while I'm starting the algorithm, I will just give only the abstract of this algorithm. I will not go in depth. Hence in that case, if I'm going to have 2 endpoints as 20, 10 and 30, 18, I'm going to find delta x, so which is a simple formula where I'm going to subtract x2 with x1, and delta y is, so y2 minus y1. And I'm going to have a parameter value here. So this is going to be the decision parameter, so which will say, so as I told you, either I need to choose the y value or I should choose y plus 1. I should choose y value or y plus 1. So should I choose this pixel or should I choose this pixel? This will depend upon the parameter value. That is the initial parameter value what I'm going to choose with. Hence the initial parameter value is going to be 2 into delta y minus delta x. And later on, the next parameter value will be this formula, or it's going to be this formula depending upon which parameter value you choose. If you have chosen, if the parameter value is greater than 1, I'm going to choose this formula, else I'm just going to choose this formula. So now this is how I'm going to use the formula starting from x0, y0 as 20, 10. I'll be keep on incrementing the x value linearly. So starting from 20, 21 and so on until x2, that is 30. Whereas the y value will be 10, then I'm choosing y plus 1, then I'm going to have another y plus 1, but now I'm choosing the y itself. The value of y remains same. Again the y value is changed, the y value remains same. This is where I'm going to compute what is the y value depending upon the parameter value. It is, if the parameter value is positive, I should choose y plus 1. If the parameter value is negative, I am going to choose the same y value. This is how the basic idea how the Bresenham's line drawing is going to work. Fine. Hence, by the value what I have been computed, now this are the pixels what I have been choose. This is the same value 12 and 12. And again I'm going to choose y plus 1, y plus 1. Again the same value of y, which is 16 and 16. So this is how the complete Bresenham line drawing algorithm is going to work. And this algorithm should work for different types of slopes. And there are 4 types of slopes, as positive slope, the negative slope, the zero slope, and an undefined slope. So your algorithm should work for all these types of slopes in your program. Hence now we'll see how exactly this is done. So we'll shift to program. So now this is going to be the default APIs which I'm going to use. And if you want to understand how this API is going to behave, or if you want to know more about this APIs, the basic APIs what I'm using, you can just check out my previous video wherein I've given you in detail what is the usage and how this API should be used. Fine. And this is going to be a 2D program, hence a single buffer is more than sufficient for me. So in this term, so now my program should work in the coordinate system as I have been shown here. So this should work in the coordinate system as origin being at the left bottom, and so 0 and left is 0, bottom is 0, and the right value is 500, a second parameter is 500, and the top value should be 500. Hence I'm going to have this particular coordinate system whenever we are going to have the coordinates, so which is going to be the type what I'm going to work with. Fine. So now keeping this coordinate system, now we will start to draw a line. So now whenever I want to draw a line, the first job is I do need 2 points. And for that, so let me declare the variables as x1 and x2. I'm going to have x1, x2 and y1 and y2. So rather than putting in this order, let me put it as x1 y1 and x2 y2. Fine. So now let me initialize these variables to the very first point what I'm going to have. Now for example, let me give this value as 120. I'm going to use as 120 and let the y value be 50 and let this value be 300, and I'm going to give this as 350. Fine. Now this is the 2 endpoints what I'm giving. The first endpoint, and I'm going to have the second endpoint. Fine. So now once this is done, I need to draw the line. Using the GL points. To do so, my first job is I need to work with the slope of the line. I need to have what is the slope of the line is going to be. Hence, I am going to find the slope, something called as m. So m equals, I'm going to find the slope using, so y2 minus y1, so divided by x2 minus x1. Now this is the slope what I'm going to find with. Fine. So now when I'm going to find the slope, now what if x2 minus x1 is going to be a straight line. What happens if x2 and x1 is going to be same for the undefined slope? Then it's going to be something like divided by 0, and so we will just even address this issue. So if x2 minus x1, if it is x2 minus x1, so let me put this in the brackets. If it is equivalent to 0, if it is equivalent to 0, in that case I do not need this formula. In this formula I am just going to remove x2 minus x1 completely. Fine, and I am going to have this in the else. So this is the slope formula what I want to supposed to have at the first set. So now I am going to find what is dx is going to be. This is just x2 minus x1, and I need to find what is dy. This is going to be y2 minus y1. Right? Now I know what is the dx value, I know what is the dy value. So now once I'm going to have dx and dy value, so now I'm just going to find the first parametric value. That is the first, where I'm going to have p equals, so p equals 2 into, so dx minus, or it is going to be dy minus dx. The first initial parametric value what I've discussed about. Based upon this parametric value, so we are going to decide whether it's going to be y or it's going to be y plus 1. And for that reason I do need the first initial parametric value. So now how many points I need to find? I need to start from x, and I should reach until x2. And for that case, so let me say this as x equals x1, and I'm going to have y equals y1 initially. So now I need to have the loop. I need to have the loop where x is going to be less than or equivalent to x2. That is, now this loop is going to work from x equals x1 until x2. I'll reach until x2. The x should be keep on incrementing. Hence in this I'm just going to have x equals x plus 1. Just increment the loop, and the loop will go from x1 until x2 with the increment of 1. So now inside this loop I need to draw the point. Hence I'm going to have GL. I'm going to have GL vertex. I'm going to have GL vertex 2f. And the first point what I'm going to draw using the x and the y. So initially it is x1 y1, and the first point I'm going to draw. So now let me put this entire loop inside GL begin, which is going to be of GL points, and this entire loop should be enclosed between GL begin and GL end, because I'm using GL vertex inside the for loop. Fine. So now this is where I'm going to draw the point. So now this is going to draw the point, and x will be incremented by 1. But now what happens to the value of y? So now how do I increment the value of y? Now the value of y is not just y plus 1 every time. The value of y is going to be y plus 1, or the value of y will be same as y. It depends upon the parametric value. That is, now whenever the parametric value is positive, hence if the value of parametric value p, whatever I have been founded here, if it is going to be greater than or equal to 1, in that case I need to increment the y value. If it is less than 1, else I'm just going to have this as y equals y. Is it fine? So now when you're going to have y equals y plus 1, before I'll start the loop, I need the next parametric value. I need to have the next parametric value to find what is the next y value decision is going to be, because it's the initial parametric value, but next I need what is the next parametric value I'm going to choose. So if I'm choosing y equals y plus 1, I'm going to have a different formula to find the parametric value, and the parametric value now I'm going to find using p equals, so p plus, so 2 into dy minus 2 into dx. So this is the formula what I'm going to use. So now if if I'm just going to have y equals y, if I'm choosing it as y equals y, in that case the formula what I'm going to choose is similar to this, but the term dx will be vanished. I need to remove the dx complete content, hence I'm going to have so p plus 2 into dy. So this is the formula what I'm going to choose or use according to Bresenham's line drawing algorithm. Fine. So now once I'm going to have this p values, now this will loop back, and it's going to draw the line for me. So I think this is almost done. So I have been founded the slope, and I have been founded the what is the value of y is going to be, and I'm just going to choose what parameter value I'm going to find it out. So let me compile this program and check it out how this is going to work. But before that, I need to declare few variables. So hence gl float, that is the slope what I want, and the parametric value what I need, and the dx and the dy value which I'm going to use. Along with this, I'll be having x and y value also. Fine. And now let me compile this program. Fine. Now there are no errors. Let me execute this. Now this is going to draw a line. And now just check out this output. Now this is not exactly what we have been defined with the points. This is 120, 50 is working fine, and even x2 is 300, but the y value 350 was supposed to be somewhere here. Hence there is problem with this y2 value, because if I am going to say this as y value, so this is going to be a different slope. This is going to be the slope which is going to be greater than 1. But right now, whatever the algorithm we are putting here, this is going to be the slope which is less than 1. And so we'll just change the value of y, and later on you will see how we are going to draw even for the y2 value is 350. But right now, this is giving me slope more than 1, so which I need to address it in a different way. Right now I need to address this for less than 1. Hence for that case, I'm just going to change this value as 250, or let me give this as 200. Now this algorithm should work fine for this given value. And so let me execute this program again. Fine. Now this is going to work for 200. And even if I give it for 100, so this is going to work. So anything above 250 will give me a different type of slope. Fine. Now this is going to work fine for the basic slope whatever I am going to have. The slope which is going to be less than 1. This is working for the slope which is less than 1, and that is what we are going to have. So when I am going to work with the slope, this is going to be greater than 1, but whatever the equation I have been put here, this is for less than 1, the slope which is going to be for less than 1. So similarly, I need to program it for the slope which is greater than 1, but we will just come to that point later. But now just look at this. So now this is working for the slope which is less than 1. Along with that, now what if I'm going to give the x2 value as 120, the second endpoint as this, and this is the first endpoint. So in that case, the value of x1 will be greater than x2. In that case, this loop is not going to work, because I'm starting x value at the maximum value or the greater value, and I'm comparing this with the lesser value where this condition will fail. Hence either I need to have a different loop for that, or else the one trick what we can do is I'm just going to swap out this. I'm just going to swap this points itself. So swap out the endpoints. So to swap the endpoints, I'm going to check what is the y value is going to be, or what is the x1 and x2 value is going to be. Depending upon that value, I'm going to find what is the dx value is going to be, what is the dy value is going to be, and so on. And for that reason, I'm just going to check if the x2 value, or if the x1 is going to be greater than x2. In that point I need to swap. Hence I'm going to say t, which is a temp variable. So t equals x1, so x1 equals x2, and x2 equals temp. Now this is going to swap the x value of the point, and I need to swap out the y value. and so I'm going to have y1 here, and this is y2, this is y1, and this is y2. So now I'm just using a small trick so that I can avoid few more variables which I'm going to declare later. Fine. So now this is done. So now once I'm going to have this as the equation where I'm going to swap out the values, and I told you this entire block is going to work for the slope which is going to be less than or equal to 1. This is going to work for less than or equal to 1, or I can say less than 1. And this value, whatever the value I'm going to give here, so the slope can be negative or it can be positive, whatever it is. When the slope value is going to be less than, I'm just going to use the FAPS value. So whenever the slope value is going to be between 0 to 1, that is 0.5, 0.7, in that case this slope is going to work. Anything which is greater than 0 or greater than 1, I need to program it in a different block. Hence I'm just going to block out this entire thing in this if condition. Until this point I'm just going to block out in this entire if condition. Fine. Now this block is going to work for the slope which is going to be less than 1, the slope which is going to be less than 1. And now just observe one more variation here. So now I'm just going to have such lines with the slope which is going to be less than 1, but if you observe, the x1 and x2 value, or the x1 is lesser than x2, but if you observe the y value y1 is greater and y2 is lesser. So in this term the y value should not increase, the y value should decrease. That is what I am making out over here. Now in this case the y value is going to increase, but the y value should decrease for this particular case. And so now depending upon the value of the slope, if the value of the slope, hence if the value of slope is positive, that is if m is positive or equivalent to 1, I am going to increment the y value. If the value is going to be less than 1, in that case I am going to decrement the y value, and so y equals y minus 1. Now this is done for the case which is going to be less than 1. So similarly I need to copy this entire thing. I'll be copying this entire thing and paste it out as a different block, and now this is going to work for greater than or equal to 1 slope, the first example what I was talking about. And now in this case, so wherever I'm going to have x, I should replace this with y. Hence I'm going to have y1 if it is greater than y2. So the swapping I need not interchange here, and in this it remains same, and I'm just going to have parametric value as dx minus dy, and this remains same. And in this case I'm just going to have y which is less than y2, and this is going to be y is going to be the incremental constant increment axis now, and x is going to be computing. Hence this is going to be x equals x plus 1, this is going to be x equals x minus 1, this is dx, this is dy, and this is going to be x equals x, this is going to be dx. So if I just replace y with x, this is going to work fine. So compile this, and the t variables should also be declared for the temp and for the swapping, and so I'm going to compile this. So there are no errors. So execute this. Now this was not the line which I was expecting, because when I'm going to give the points, as 100 and 300, so this is not 300, somewhere it was supposed to be somewhere over here. And so now we'll just see what is the problem this code has got. Fine. So now all these things right. Yeah, well, one thing we are missing out here is, now this should be FFs, because when the value of x2 is greater than x1, so still I need to work with the positive values itself, and so FFs with these two values. So similarly even in this block also I need to change. So FFs, and this is going to be in the bracket, so FFs Again, this is going to be in the bracket. Now just check it out. When I'm just going to compile this and check it out, whether it's going to work fine for the given points or not. Compiling this and execute. Still the error of the line persists, so we'll see what exactly is going to happen. Okay, now we'll just change the slope value, say it as m is less than 1, and now just check out this program. Yeah, now this is going to work fine, and now this is working for the given input. And let me change the line for the same output or line which I was working with, that is 350, and just check it out. Yeah, this is working fine. And let me give a different type of line, that is 250, and it's going to be 250. And let me give this point as 300, or this as 400. This is going to be 50. And check it out for this line. Yeah, even this is working fine. So let me give the straight lines and see how this is going to work. And I'm just going to use as 250 and 250, and this is 400. Or let me give this as, let the x value be same, and the y value I'll be giving this as 400. So this should be a straight line. And this is also working fine. So let me give an horizontal straight line. So where I'm going to have the y value will remain same as 250, and let me change this value as 350. If I execute this, even this is working fine. Now this program is working for all the types of slopes, and this is what all I want to discuss in this video. Thank you for watching, and if this video was useful to you, so please do comment about it and share the video with your friends. And for more such videos, please subscribe and follow my channel. Thank you.